Welcome to the March 17th edition, St. Patrick's Day edition of the Manhattan GMAT Study Hall. Today's topic is coordinate geometry data sufficiency. We did do a little bit by way of introduction in coordinate geometry back on April 1st, 2010. So I'll briefly redux the points that we did in that study hall, and then we will move on. First, though, as usual, we need to do the usual warnings about content and submissions. So let's get through that quickly so that we can move on from there. Submissions. When you submit problems via the web interface, there are some warnings, the usual warnings here. First, please do not submit problems that are too general. Entire areas like geometry or how do I solve problems faster, which could be the whole test. Please don't submit things that are that general. It's got to be something that we could reasonably cover in an hour and a half or in a segment of an hour and a half. So, something like this could be hundreds of hours. But by the same token, remember that we have a forum, and so what you need to do is sort of make a common sense decision about whether something is better as a study hall topic or as a forum topic. Like if something is so specific that we could answer it in a minute or two, then that's better on the forum. Like if it's a specific question, one problem, what's wrong with choice D here, that's why we have a forum. Here's the address for that. Same deal with personal issues. Remember that these recordings are watched by hundreds of people, so some of them are even watched by a couple thousand. So you don't want to submit one person's study plan and say, what do I do? We have a place on the forums for that as well. We have the general questions folder. So that's where you should submit that. As for what you should be submitting, we want topics of intermediate depth. That means halfway between this and this. You don't want to ask about all of critical reasoning at the same time, but you also don't want to ask about one problem. Instead, you want a medium scope kind of department to ask about. So you could say, last time, 2 weeks ago, the session was on strengthening weakening problems, because that's, decently focused in scope, medium scope. In geometry, today we're doing coordinate geometry data sufficiency. That's a decently focused area. And please don't forget, if you send in problems, you need to send in a source. If you don't send in a source, we have to ignore the submission because we don't want to be stepping on any toes when it comes to copyright. Official guide, you cannot submit. Do not forget this. Every time we have a few people trying to submit OG problems, please do not submit OG problems. We cannot use them. Copyright issues and all that. So also don't forget, please check the archives for topics before you post. If something has already been comprehensively covered in a previous study hall, we don't really want to cover it again. There's a question in the text box about can we look at X. This is not the place for submissions. Remember, when you look at the front page of Thursday Study Halls, that's where you submit topics. I mean, that is the right scope of topic, but we don't take topics on the fly because we have to prepare the study hall. So go ahead and submit that here on that front page. Okay. Let's go ahead and get started. What I want to do first is to review some points that we made about coordinate geometry in April 1st. In the April 1st, 2010 study hall. So I'm going to just go ahead and import a graphic from that particular session. It'll take a second to load onto your screen, and then I'll tell you when it should show up. Okay, there you go. So these are things, it'll show up on your screens in just a second. these are the points that we made about coordinate geometry on April 1st. So we're going to reference these points as we go through the problems that follow. But these are the two principal approaches to coordinate geometry on the screen. You can approach coordinate geometry algebraically, or you can approach it by visualization. Again, a fuller treatment of the material shown here is if you want to go ahead and watch this recording for 4/1/2010. But the deal is that, unlike most other areas, in coordinate geometry, you almost always have more than one way to view identical statements. For example, if you, let's do this with a specific example. Let's say I tell you that, let me go ahead and resize this graphic real quick. Let's say I tell you that the slope of a line is 2. The slope of line L is 2. If you're doing this algebraically, in the text box, go ahead and tell me what's one way that you could interpret this algebraically? Like, what's one thing that you could do with that statement from the standpoint of algebra? Yeah, one thing you could do is to take mx plus b and plug in 2 for m. So that would give an equation like this. Or you could actually write the slope formula. Like 2 is the quotient of difference in y's over difference in x's. So those are supposed to be subscript 1s and 2s, but it takes a long time to do subscripts. So yeah, let me just do it real quick. Subscripts. Let's see. So that's that formula down there is definition of slope. It's the difference in y's over the difference in x's. So these are two different things that you could do with a statement about slope if you were doing algebra. Now, with visualization, the deal is that the way you're going to interpret these things is different. With visualization, the question is, what does this look like? So if you're doing this visually, what is it? There's no way to really answer that in the text box, so I'll just draw it. What does it look like? It goes up from left to right. Specifically for every 1 unit, that's 2/1 is the slope. So for every 1 unit that it goes over, it goes up by 2 units. So that's what it looks like from the visual standpoint. And then one thing also to think about when you consider a problem visually is you do need to imagine restrictions and freedoms of movement, meaning what can I do with this object and still maintain the properties that I've got, and what can I not do with this object. So for instance, if you have a fixed slope, then one restriction that you've got is that you can't rotate that line. Because if you rotate the line, then you will change the slope. But freedoms of movement, who can tell me in the text box, how can you move a line with slope 2 so that it will still have slope 2? Like, what can you do to it? Yeah, you can slide it. You can slide or translate. If you like formal language, you can say translate. If you don't like formal language, you can say slide it around the plane. Which is, yeah, changing intercept is the same thing as shifting something up and down. So, right. So that's another equivalent answer. Someone saying in the text box, so the value of b is not critical. I mean, you know, depending on what else the problem tells you, you might find out what the value of b is. But this is just this statement. I mean, if you only know the slope of a line, then yeah, you know nothing about intercept. Okay, smiley face if this is all good. And if you have any questions, go ahead and throw those in the text box. Remember, your smiley face is over there. It's a button that you can just press. And if so this is the basic deal. One piece of insight worth rehashing from last time is this. if you encounter a problem that you cannot tell right away whether it is algebraic or visual, you're better off trying visual approaches first because they're very fast. Like the problem with algebra is that if it doesn't work, then you're going to sink a lot of time into it. Because, you can push variables around the page for several minutes before you decide to give up. On the other hand, the good news about visual approaches is if a visual approach does not work, you will know that in like 5 seconds. Like if you don't know what something looks like, you're going to realize that really quickly. So if you're unsure which of these to try first, it's always better to go with visualization first because it's very fast. All right, let's move into some problems and let's see what we can get from them in terms of general takeaways. So, all right, by the way, a quick review. I see some new names in the list, so some of you may be first-timers here. Just a quick review in case you are a first-timer. When we post problems on the board, here's what you do and what you don't do. When problems are posted on the board, what you should do is there's going to be buttons. You should answer the question using the polling buttons at left. Let me take a quick picture of those and show you what those look like. You should see the appearance may be a little bit different depending on whether you've got a Mac or PC or depending on whatever other version of Illuminate you're on. But the polling buttons should look something like that. And those should be over there by the list of names. If you see these polling buttons, give me a smiley face. Make sure you let me know that these are legit. Smiley face if you see them. Okay, good. What you should not do is when you answer the polling button, you don't answer the question in the text box, please. Do not answer the question in the text box. Because then what you're doing is you're revealing your answer to everybody else who's also taking this question, and that's not valid preparation for the test anymore for those people because it's not a group activity. It's just an individual test. So when you use the polling buttons to answer the questions, when you use those polling buttons, you're keeping your response private until we post the statistics to the screen. So, all right, let's look at a question. Here we go. Bang. We'll go ahead and put a timer on the screen. There's the timer. Go for it. Remember, please answer with those polling buttons. Okay, that's about 2.5 minutes, so please indicate. If you have not indicated an answer, please indicate one. Remember using these polling buttons. Remember, this is the GMAT. If any of you are not answering the question, do remember about this test, that is not an option. Like you can't not answer questions. So make sure you don't take that kind of habit into your studies. Okay, there's still a Cyrus, Chan, and I think Brandon. Brandon's got an answer. Okay, here's the class statistics. This one you did pretty well, so we'll try to make this pretty quick discussion. Popular answer C, that's also the correct answer to the problem. We still had 3 non-responses. One of the non-responses is me. So, but you got to answer the question. I mean, remember, this is not a test that allows you not to answer questions. So, okay. line K passes through the origin and through the point, arbitrary point A, comma B. So what's the significance of, go ahead and tell me in the text box, what's the significance of that green thing right there? AB is not equal to 0. So you can tell me what that signifies. Someone says either A or B equals 0. That's actually the exact opposite of what it signifies. This is a number property statement. If it says not equal to, maybe you missed that. If you did, make sure you take that down as a lesson about yourself. Make sure you need to know that you need to double check your reading of these equations and stuff. So this means that neither number property conclusion is neither of these is 0. What that means visually is that the line is not horizontal or vertical. Because if the line, it goes through 0, 0. So if it were a horizontal line, then it would be the x-axis and all the b's would be 0. And if it were vertical, it would be the y-axis and all the a's would be 0. So that's important because you know at least that you're going through the quadrants. The line is not vertical or horizontal. That's a takeaway. Okay, is B positive? So the question is about the y-coordinate of this point. Is the y-coordinate positive? So number one, it's probably better to do this visually. I mean, there presumably are algebraic approaches of some type, but they're kind of a pain. So let's do a visual approach. Statement 1. If the slope is negative, then tell me in the text box with words, what does that look like? Or actually, there's a symbol on your keyboard that you can type that kind of looks like that, if you'd rather. Yeah, the backslash, right. It slopes down from left to right. So you got a line that does this. Like, we don't know what the scale of this diagram is, but it slopes downward as you go to the right. So the problem is this is not sufficient because remember that A comma B is a random point of this line. So A comma B could be here, right there where that red dot is, or A comma B could be here. So remember, it's a data sufficiency question, so this would constitute a yes to the question, but this would constitute a no to the question. So this is not sufficient. By the way, let me pause for a second, since all of the problems on today's thing on data sufficiency. Let me pause and give a few words of advice about that. If you have trouble with the data sufficiency format, which a lot of people do, but if you ever find yourself missing data sufficiency problems because of the way data sufficiency works and not because of the actual math, then before you start the problem, make sure you, at least in your head, answer the following 3 questions explicitly. The first question is, exactly what am I trying to find? This is important because if you find the wrong thing, you will usually get the problem incorrect. Second question is, what would be sufficient? Like, what's good enough to be sufficient? And then what would be insufficient? So let's take this problem that we're working on here. And just to make sure we're on the same page with that, here's the problem. Let's answer our 3 questions. So 1, exactly what is the problem asking for? That we already talked about. We want to know whether the y-coordinate of A, B is positive. Someone tell me, okay, what would be sufficient in the text box? Sufficient to this question would be what? A quadrant you don't necessarily need. I mean, a quadrant would be good enough, but that's a little bit too much information. Because, for example, if you were in eta quadrant 1 or 2, this would be sufficient. The sign of A and B is also too much. You don't need, and A and B itself is way too much. Like you don't need to know. All of the answers currently in the text box are too much information. I mean, they would work if you got them, but that's more than you need. Like the question is exactly what do you need to be sufficient? So, I mean, here. Let me help you. Let me help you guys fill this out real quick. Fill in that blank. I'm not asking for anything that requires understanding of the problem here. So for you guys talking about slope and stuff like that, too much reasoning. I'm just looking for exactly what are we trying to find in the problem, because a lot of people are not as clear on this as they think they are. Like we don't care about slope in this problem. I mean, at least not ultimately. I mean, slope might help us find stuff, but that's got nothing to do with sufficiency. Yeah, okay, there we go. So someone is saying the sign of B can be determined. Here's the kind of answer I'm looking for here. If B has to be positive, then that's sufficient. And also, if B has to be negative, then that would also be sufficient. That's what I'm looking for, a very basic understanding of the problem. But a lot of people don't get to this point. Like a lot of people are like, oh, I have to find a quadrant, or I have to find a slope, or, well, no, you don't. Like this is what you have to find. The question says this. Make sure you immediately can say sufficient means either this has to be positive or this has to be negative. This you got to figure out before you look at any of the facts in the problem, because you have to make sure that you understand what is it I'm trying to find. Okay. Questions so far about this? Both, well, if it can be, yeah, but if it has to be positive, then no, that would be sufficient. Okay, 3, what would be insufficient? So if what happens, then the statements the statement or statements is or are insufficient. Who can tell me what goes in that blank? Yeah, if B is either, if both signs are possible. If B could be either positive or negative. I mean, this is very basic, but a lot of people don't stop to do this process. So, I mean, because a lot of the answers in the text box here are like if you answer these blanks with slopes, what you're doing is you're thinking of like 3 or 4 steps at the same time, and that's not what you want to do. You want to lay out exactly what is it that I'm trying to find first, and then you attack that. So we're going to keep doing this for each problem that we see today, answering these 3 questions. This is super important. You have to have your feet on the ground before you start doing these things. So questions if the stuff, smiley face if the stuff in this box makes sense. Okay, so back to that. That's why this is insufficient, because there's your yes and there's your no. There's your positive and your negative. Okay, statement 2, A is less than B. Statement 2 just means the x-coordinate is less than the y-coordinate. So where exactly does that happen in the plane? Hard to describe in words, so I'll just go ahead and show you. If the x-coordinate is less than the y-coordinate, then that happens in the following, and you may want to get this as a takeaway. You may want to remember where this happens. This line right here that I drew in gray is where the x and y coordinates are equal. That's the line where y and x are the same. So x is less than y on the side of this line where the x coordinates are smaller. That's this zone right here. So you're about to see some highlighting up here in a second. The purple highlighted side of that line, this is the whole area of the plane where x is less than y. So smiley faces, that makes sense. That purple zone. That's the area of the plane where x is less than y. So what that means is that your line goes through somewhere in that area. That's a problem because just about any line will do that. In fact, any line will, unless it's that exact gray line. So like for instance, if you draw this green line right here, then that's got a positive coordinate on it right here. And it's also got a negative coordinate on it right here. Or if you want to look at although we don't care about that last point because that doesn't satisfy statement 2. This would be a point satisfying statement 2 with B positive. And then here's a line. Here's another point satisfying statement 2. This time it's negative. So this is a yes to the question, but this is a no to the question. So that's also not sufficient. Questions about that? If you put them together, then let's see what we've got. If you put these statements together, then you need a negatively sloping line that goes through that area. If you think about that, then your point's got to be in the blue area here, but your line's got to be negatively sloping. So if you combine those things, then your point's got to be in this quadrant right here. So that's enough to guarantee that the y-coordinate must be positive. Any questions about that? If you have questions about that, that's sufficient. So the answer is C. Questions about that, please type them in the box. I'll wait and see if a couple of you are typing, so I'll wait and see what you are typing. Okay, let's do something fun. Let's try this problem right here. I'm saying one more person's typing a question, so let's see what that is real quick. Okay, if someone says did not understand why 2 is not sufficient, there's this. I mean, that's a very general statement, so I would have to respond to that by doing this entire explanation again, which is not really, that wouldn't really make sense to do that. So if you could tell me more specifically what it is that you didn't understand, then I can try to address that. Otherwise, because I can't really repeat this whole explanation all over again. Let's see what you're typing. Right, but the question is not about quadrants. The question is this. Remember, this is why you really have to set these things out at the beginning of the problem, because your questions are showing that you're not really understanding these basics before you dive into the problem. Like, we don't really care about quadrants. We just care whether our point has to have a positive y or a negative y. If y must be positive, then sufficient. If y must be negative, then sufficient. If y could be either positive or negative, then not. So if you look at these two possibilities drawn right here, this one's got a y that's positive, and that one's got a y that's negative. So that's insufficient. So, okay. Remember, you got, I mean, I think this is a big problem with lots and lots of people with data sufficiency. People do not take the time at the start of the problem to do this. This is super important. You have to do it. You have to know what you're trying to, I mean, it sounds like common sense when I say it this way, but you have to know what you're doing before you do it. You can't just dive into a problem and just kind of wander around. So, okay, try the following. This one, by the way, all the problems on today's study hall are from GMAT prep, except this one, which I just kind of made up for kicks. Before we do this, let's talk about these questions. Oh, wow, that's big. Let's make it resize that. Okay. Blah, 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 blah. Sorry about the weird sizing here. Okay, let me resize this text. And then that, we don't want that text down there. We want that here. Okay. Wow, that's a hot mess. Sorry, guys. Okay. Let's answer these questions. Someone tell me, what is the problem asking for? The problem is asking for the sum of A and B. By the way, when you do this, make sure you also realize what the question is not asking for. It's asking for the sum of A and B. What is it not asking for? Text box. Like, what do you not have to find? Very, very super important here. Yeah, you don't need to find A and B. We did talk about this in a previous study hall, but if a problem asks you for a specific bit of information, you really need to focus on that. Like in this problem, if you think you need to find A and B, you're probably going to get it wrong. So super important. So in the last problem, if you think you had to find the actual coordinates, you wouldn't have gotten that right either. All right, now what would be sufficient? Someone writing A parallel to B, I don't know what that means because A and B are numbers, so they can't really be, numbers can't be parallel. Okay, what would be sufficient? Like what exactly do we need to be sufficient in this problem? To know if A and B can be found? No, that's too much. Because even if we have, that's what we just got done saying. If we find A and we do not have to find A and B themselves. And the way these problems will probably work is you probably won't be able to find them. But you might still be able to find the sum. Slope? No, slope's got nothing to do with this. I mean, this is a very basic question. You're not thinking about doing any geometry yet. You're just making sure you know what you are doing with that. What exactly do we need to find? Yeah, PS is correct about it. You need to find, people talking about slopes and sides and all that, no, way too many steps at once. You guys are trying to be chess masters and think like 5 steps ahead. Not how these things work. Like you really cannot do all these steps in your head at the same time. What you need to be able to say right now before you move on is if we have one value for the sum, then that's sufficient. Like if A plus B has to be some number. Okay, smiley face if that makes sense. If there's one number for A plus B, then that's sufficient. Okay, then what's not sufficient? Text box, please. There's more than one value for the sum. If the sum of A and B can have more than one value. I mean, again, I cannot emphasize the importance of this enough. You really have to knock these things out before you proceed with the problem. So what we're trying to find here is whether A and B can have a single sum or more than one sum. Okay, now that we know that, let's do it. Here's the problem. We'll put it onto the next page. And there you go. Okay, I'm going to give you the polling box again, and we'll go from there. Here's a timer. Have fun. Okay, my lovely people, most of you have something chosen. If you don't, please choose something. By the way, I made up this problem myself just now, so there's no gauges for difficulty level or anything like that. But here's the stats on the screen. Let's talk about it. So we've got, I mean, it looks like all of you guys realize that you guys, there's no B's or D's here. So you guys did definitely realize quickly that statement 2 is not sufficient. Because if A and B are just random integers, then the idea is that, visually speaking, statement 2, the rectangle could be huge or it could be small. So in other words, if the rectangle is huge, then you would have a huge sum of A and B. Or if the rectangle were tiny, then you would have a tiny sum of A and B. So that's not sufficient. Questions in the text box, smiley face if that makes sense. Okay. What about statement 1? The area of rectangle ABCO is, by the way, O is the origin. If you see O in a problem, O is always the origin. They do tell you that in the official guide. They do tell you that in the intro to GMAT prep. O cannot be a point other than the origin. So, all right. What is the area of, like, what do you get out of that? If the area of rectangle ABCO is 35, yeah, then we know that it's at least 1 by 35, or we know that it's 5 by 7. That's not really going to tell us, though, about, I mean, because these 4 values could be, I mean, that means AO could be 1, 5, 7, or 35. So AO could be any first quadrant segment with length 1, 5, 7, or 35. So this is not going to give you a constant sum. All right. Questions about that? Smiley face if that makes sense. So this is also not sufficient. Okay. All right, kids, let's talk about putting these statements together. Remember that a lot of the time in these problems would be, they make it work the opposite of the way you would think it would work. What extra is added here by the fact that A and B have to be whole numbers? Does that change anything? Okay, AutoCheck says not safe to say BA is greater than OA. Actually, it's not. Remember, this is a good point to make in general about diagrams. Data sufficiency diagrams are never to scale. because they can't be. Like if you think about it, scale diagram versus not scale diagram is a problem-solving issue. It's not a data sufficiency issue. Because if you think about how data sufficiency works, at the outset of a data sufficiency problem, everything is always unknown. So there's actually no such thing as a scale diagram in data sufficiency. So no, you can't really, I mean, you can assume this is in the first quadrant, because even if this were a grossly not to scale diagram, this would still be the first quadrant. But no, you can't assume that BA is longer than OA. That's a good point, just keep that in mind. Okay, back to what we're talking about. Yeah, we need to have a right triangle triple. So this is significant because remember from statement 1, our possible lengths are 1, 5, 7, 35. But let's look at how we might get those. If you have, if you have integer squared plus integer squared equals 1 squared, this is impossible. If you have integer squared plus integer squared equals 5 squared, this can work if it's 3 squared plus 4 squared is 5 squared. So you can have the 0.34 or you can have the 0.43. Notice that doesn't mean insufficient because these still have the same sub. So we need to keep looking. Integer squared plus integer squared equals 49. That doesn't work. This is impossible. And then if you've got integer squared plus integer squared equals 35 squared. 35 squared is a big number, but what you can realize is the same Pythagorean triple as this. So just times 7. So like instead of 3, 4, 5, it's going to be 21, 28, 25, or 35. This is a takeaway, by the way, if you don't know it. If you have a group of numbers that works as a Pythagorean triple, then any multiple of that will also work as a Pythagorean triple. So if 3, 4, 5 works, then 21, 28, 35 will also work. So technically AO could be 21, 28, or it could be 28, 21. Now, here's the problem with that. The problem with this is that if this length is 35, then what will AB have to be? Yeah, because remember, like, it's not a scale diagram, but at least we know that B has to be in second quadrant. And that's where the problem comes in. Because if you have OA is 35 and AB is 1, there's no way that AB is going to get you into the second quadrant. Like if you, we're kind of running out of room to draw this, but if you have one of these possibilities, these two down here, then what you're looking at is something that's going to look like this. You're going to have this massively giant rectangle in this direction and a tiny side in the other direction. Like it's going to look like that. So that's not what the picture looks like. So the only possibilities that are actually going to look like the picture looks are if this is 5 and this is 7. Because 35 by 1 is not going to give you the right picture. So these are your only two possibilities. Yeah, it's not drawn to scale, but quadrants are not a scale issue. Like this point does have to be in the second quadrant. I mean, this doesn't have to be longer than that, but they can't lie about quadrants. Like even when a diagram is not a scale diagram, if things are in a certain order or placed in certain ways relative to each other, that's not a lie. So like just as we know that point A has to be in the first quadrant, we also know that point B has to be in the second quadrant, because this is the intersection point. So this intersection point is not a lie. If the diagram shows that, then it's there. So, I mean, yeah, I wrote this problem. Honestly, this problem is probably a little bit too hard, but there's still some good takeaways here. Like for instance, so this is the answer C, because Cyrus is what relevant? Cyrus says, is that even relevant? What exactly are you talking about, sir? Yeah, Cyrus, it is, because if B could be in the first quadrant, then these would be legitimate possibilities, and then you'd get insufficient. Like, because if you could have a 35 by 1 rectangle, then you would get massively different sums for A plus B. So yes, it matters hugely, because if you could have this possibility, it would become insufficient. But as it stands, you got to have 3, 4, or 4, 3. Those both have 3 plus 4 equals 7 as a sum, and so you are sufficient. Okay, takeaways from this problem. The Pythagorean triples, that's a big one. If you have an integer length with integer coordinates, you have to have numbers that form a Pythagorean triple, like integer squared plus integer squared equals integer squared. There are not a lot of those. And you should be familiar with the ones that do exist in small numbers, like 3, 4, 5, 5, 12, 13. There's also the takeaway that if something is a Pythagorean triple, then so is any multiple of that. So if 3, 4, 5 is a Pythagorean triple, then so is 21, 28, 35. These are all important realizations. Okay, to be honest, I just wrote this problem like 5 minutes before the study hall. So it's interesting the way it worked out, because I actually meant this this wasn't what I intended to happen. So, but it still works out. It's still a good problem. And it still works out to have the answer that I originally wanted it to have. Okay, questions, any more questions about this problem? Again, yeah, the problem's kind of obnoxious, but yeah, it's what you can learn from it is what matters. Okay, no further questions. Let's move on to another one. But that, by the way, is the only problem on today's presentation that is not from GMAT prep. Other than I did make 2 versions of the next problem. But here's the GMAT prep problem. Again, please answer using the buttons. Here is a timer. Have fun. Okay, my beloveds. That's about 2 minutes and 20 seconds. So let's pick something. That means, remember, this is the GMAT. There's no such thing as not picking an answer on the GMAT. If you stare at the GMAT will stare right back at you, and it will win the staring contest. So even if you have absolutely no idea what is going on in this problem, you need to pick an answer. That means there's Cyrus, there's Manas, and there's my name display is messing up on me, so I can't tell who else. If you are here, Cyrus, I don't see a choice from you, so try clicking the button again. Okay, there you are. Manas, I don't see a choice from you. And yeah. Okay, here are your statistics. These statistics are showing me that maybe people aren't really understanding the problem. So let's do this again. Those purple words. We need to get that out of there. But all right, let's talk about this. Let's fill these things in. What is the problem asking us? The problem is not asking us about it. That's from the last problem. The problem is not asking us about coordinates anymore. What is the problem asking us? The problem is, okay, someone is saying unique value of R and S. Absolutely not, no way, no way, no how. If you think this problem is asking for a unique value for R and S, then you really need to go back to first principles of data sufficiency and start from the ground. Because this is a question that asks a very detailed question. This does not say what is R comma S. And so that's not what it's going to mean. Like if you are interpreting this question as find R and S, do not even bother. You're not going to get it right. Like in other words, if you're ignoring this whole thing about 3x plus 2, don't even do the problem. Like you won't get it right. So, all right, yeah. What is going on here, the takeaway is this. Satisfying an equation means that if you plug into that equation, then it works. So if the line contains a point, what that means is that you can plug the point into the line, and it works. That the equation works if you plug in. So if you plug in RS, that means S equals 3R plus 2. So this is really almost not even a coordinate geometry question, because as soon as you figure this out, you can ignore coordinate geometry for the rest of the problem. But I mean, really, I don't mean to sound harsh when I say this, but if you look at this whole question with all of these words in it, and all you get out of that is I need to find R and S, then whoa, no. Then that means you need to go very much back to the first principles of data sufficiency and start all over again. Because I mean, you really have to process these questions. Like if you're ignoring everything about the XY plane of the line when you read the problem, you're never going to get it right. So I mean, that might sound harsh, but that's the truth. I mean, like, same thing with this problem that we just saw here. Like, if someone reads this and thinks that they have to find the point AB, don't do the problem. You're not going to get it right. Like, you really have to make sure that you understand what the question is asking you for. So the problem is asking you for is S equal to 3R plus 2? Since this is a yes-no question, for all yes-no questions, there are two forms of sufficient. So let's fill those in. Somebody help me out here. What's sufficient? Okay, if S has to be 3S plus 2, if S must be 3R plus 2, then that's sufficient. What else would also be sufficient? Yeah, it would also be sufficient if it were never. If S cannot be 3R plus 2. Then that would also be sufficient. Okay, make sure that you have these feet on the ground before you do anything. Otherwise, you will get the problem wrong. Because most of you have this problem wrong. So And if you do, it's probably because you are not figuring these things out before you just dive headlong into the problem. You can't do that. You have to look before you leave. What would be insufficient? Text box, please. This question. What would be insufficient? Multiple values of S or R? No, that's wrong. Yeah, it's this. This is a yes/no question. Insufficient means 0 has nothing to do with it. Sufficient means it either has to be yes or has to be no. Insufficient means could be either one. So if S could be 3R plus 2, but could also be other than 3R plus 2, then the statement is insufficient. Okay, I mean, again, people are having a surprisingly hard time filling in these basic blanks, and I think that's part of why, because most of you got this. The answer to this problem is not D, which half or more of people picked. So if you're picking that, it means that it doesn't mean you don't know how to do algebra. It means that you're not learning how to read these problems correctly. Like, it means you're not answering the right question. Because a bunch of you said things that are not right. Like, a couple of you said you had to find R and S. That's totally not true. A couple of you said that if you got different values for S or R, that would be insufficient. That's also not true. The only thing we care about is whether S equals 3R plus 2. That is all that matters. If there are tons of multiple values possible, but they're all 3R plus 2 equals S, then we're fine. So make sure you got this. Because if you don't have this in your hands, then you are basically just wandering around in algebra land and guessing. So let's take a look. So Jay's here, that's incorrect. That's not how factors work. I mean, like, if this product is 0, that doesn't mean that both of them are 0. It means that either this is 0 or that is. That's where you're going wrong with that. Like, you're interpreting that to mean that both factors have to be 0, but that's not true. Okay. Here's the problem again. So at this point, as soon as we figure this out, we are done with coordinate geometry. We don't need to think about lines here at all anymore. So, like, big takeaway is if the problem talks about point blah, 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 being on the line or curve with equation blah, 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 then this is probably not a coordinate geometry problem at all. This is probably a pure algebra problem. Like, just plug in and then ignore the geometric aspect, as ironic as that is. So, like, that's what happens here. This is not really a geometry problem at all. Like, the line is just a stupid distraction. Like, we don't care. Like, we're trying to figure out whether S is 3R plus 2, and then we're done. So, okay. Is S equal to 3R plus 2? Let's talk about it. Statement 1 means either, this is a big takeaway if you didn't get this right, if the product of two factors is 0, then either, not both, either of the factors could be 0. So that means this is either, not both, S equals, I mean, if 3R plus 2 minus S equals 0, then that means that 3R plus 2 is S. Or this. So this would be a 3R plus 2 equals S. But this is 4R plus 9 equals S. Now remember what the question is. The question is this true? So if 3R plus 2 equals S, then there will be some points with, I mean, those points will all have, these are all yes to the question. Because that's the question. On the other hand, if 4R plus 9 is S, then most of these points will not also satisfy 3R plus 2 equals S. So many no's to the question. There's a question in the text box about 4R plus 2. I don't know where you got that from. Maybe that's supposed to mean 4R plus 9. If that's supposed to mean 4R plus 9, then yes. Jay's out here. If that 2 is supposed to be a 9, then the answer to your question is yes. All right. So this is insufficient. Questions about this? Smiley face if this makes sense, because most of you thought this was sufficient. So smiley face if this makes sense. Okay. Statement 2 is not sufficient for more or less exactly the same reason. When you hear negatron, when you hear about C-traps are things that are like literally the most obvious thing in the world. Okay, like make sure you don't overextend the concept of a C-trap. Like a C-trap is like, wow, if I have C, then all I have to do is 1 plus 2 equals 3, that kind of thing. I mean, if it's not like, if it's not reduced to something that's like grade school math, then it's not a C-trap. So a C-trap is not like an over-generalizable concept. Okay. If you put these together, then both must be true. C-traps are not the point of today's lesson, so I don't want to digress into that. That's dealt with in other study halls. In particular, if you want to, the April 1st, 2010 study hall does discuss that to a certain extent. Okay, okay. Both of these statements have to be true. The first statement is this: either 3R plus 2 equals S or 4R plus 9 equals S. And this. Okay, we need to make both of these true. So one of these must be true, and one of these must be true. I mean, yeah, words like intersection, they don't really help. In fact, they probably just complicate the issue. Because, I mean, if you're throwing around terminology, then what usually happens is it means you stop thinking with your brain. Like, usually when people start using vocabulary words like that, it means they're not using intuition anymore, and that's dangerous. Okay. Notice it's impossible for both of these things to be true at the same time. You can't have 4R plus 9 equal to S and 4R minus 6 equals S. That is super, super important. These can't both be true at the same time. So, let's see. Since the original equation is whether 3R, can you say this equation as Cyrus, I don't really understand what you're asking me. Can you say this equation as x? I don't know what that means. Maybe explain a little bit. I mean, you can't call an equation x, but I mean, because x is a variable. Okay, the point here is this. Like, to make these both true at the same time, you could have either this and this be true, this and this and this, or this and this. But that last combination is impossible because 4r plus 9 and 4r minus 6 can't be the same number. So that means that at least one of these 3r plus 2 minus, at least one of these has to be true. And so we know that 3r plus 2 has to be s. So there. All right. That's sufficient. So the answer to this is C. Well, let's see what this question is. I rewrote 3r plus 2 minus s. Well, you don't need to call that x. I mean, well, I guess you... I wouldn't call that x because that's not an x coordinate. Like what that is that's like subtracting an x coordinate from a y coordinate. So yeah, I guess you could call it that. Notice the same thing though here. Like you need to reject the possibility that both of these can be 0. So since these cannot both be 0, or since these cannot both be true, one of those has to be. That's your x thing. So in your x and b and a approach, that conclusion is sound only because it's impossible for both a and b to be 0. If both a and b could be 0, then you'd be in trouble there. And in fact, that's the topic of the next two problems I wrote. So hold that thought. Are there any other questions about this problem that's on the screen right now? If there are, put them in the text box. That last 30 seconds was just aimed at Cyrus. So if any of you didn't know what I was talking about, it's fine. Okay, so now because I love you guys so much, here's two more variations on the same problem. So here's what I'll do. Since the problem is the same, we don't need as much of a time allotment. So what I'll do is I'll give you guys like a minute 15 or a minute 30 for each part. So do the first part. I'm going to cover up the second part. Do the first part first. I cleared out your polling answers. Here's a minute 20. Try that. Okay, lovely people, please pick something. All right, here's your statistics. Let's talk about it. If any of you thought that this is just a redux of the same problem that we just did, think again, because I love you guys too much for that. I wouldn't give you two of the same problem, because there wouldn't be much of a point in that. So something is different about this, and let's find out what that is. So statements 1 and 2 are, we got a couple answers of D, but statements 1 and 2 are insufficient individually for the same reason they were on the last page. So 1 and 2 individually, still not sufficient. Because that means that, you know, it's the same deal. Like these are yeses to the question, but these are maybes. And these are yeses and these are maybes. Now let's talk about how to combine these things. Let me color code this information. That's aqua blue, whatever color that is. That's purple. That's gold. And that's green. Okay. Green and blue are too much like each other. Let's make that yellow. And let's make that. Okay, that's good enough. All right, to put these together, what this means is that at least one of the purple and the blue box must be 0. So, and also at least one of the yellow and gold boxes must be 0. So let's see how that works. Let's see how that changes things. Okay. So that there's 4 ways in which this could happen. There's 4 combinations of this, which are, let's list those and see what happens. The first way that those could be 0 is if the blue box and the gold box are 0. The second is if the blue box and the yellow box are 0. The third is if the purple box and the gold box are 0. And the fourth is if the purple box and the yellow box are 0. Make sure I'm not writing over there. I am writing over there. Okay. Hold on just a second. Let me take the other problem and put it on the next page. Let me do it this way. Okay. All right, sorry about that little distraction. Okay, so what's happening here is, in this case, in any of the blue box is a yes and the yellow box is a yes. So that means that anything containing either of those is a yes to the question. Answer to is R equal to 3, is S equal to 3R plus 2. That means these are yeses. Anything with the blue or the yellow is a yes. But this case, we don't know. This last case here, we have to investigate that. This means that 4R plus 9 is S. And it means that 2R minus 5 is S. That's a system that we can solve, and we actually have to solve that because we don't know how this is going to work out. So this is 4R plus 9 equals 2S minus. They're both equal to R. So they're both equal to S. So 4R plus 9 has to equal 2R plus 5. And so that means that 2R is 14. Negative 14. And so this means that R is negative 7. And so this means that you can plug back in. So R and S are negative 7 and negative 19. What question are we trying to answer about these things? This is why you really, really have to set this stuff out right at the start of the game, because otherwise you're dead. Like, this is what you're doing. We got to come back to the question of, is S equal to 3R plus 2 or is it not? So we have this point and we need to judge whether it's 3R plus 2 equals S or not. That's the point. So this is 3R plus 2 equal to S? Well, let's plug in and find out. So S is negative 19, but 3R plus 2 is still negative 19. So that looks like it works. So this is still yes. So this answer is still C. Questions about that? So, notice this was a non-issue in the previous problem. Like, you could not put this together because 4R plus 9 can't equal 4R minus 6. Those are 15 apart. But in this one, you have to consider the case where this works. But freakishly, this still works out to be the same. Now, let's try. Well, if you have purple and yellow, then because of the yellow, you already know that 3r plus 2 equals f. So, okay, the yellow and the blue are good enough by themselves because the yellow tells you that 3r plus 2 equals f. So I don't have to look at it. Same thing here, and then same thing with the blue one. The blue one also tells us that 3r plus 2 equals f. I don't see any dark green anywhere. I'm sorry, I don't know what color you're talking about. Unless the colors are showing up different on your screen. Wait a minute. Well, you can't put the purple together with the aquamarine. It's an or statement. It's either this or this. So you pick one of these, you pick one of these. So there. Questions? All right, let's look at the other one. That's this one. Yeah, no, not that. Let's get that out of there. Yeah, there you go. Very similar. Let me give you about a minute and change again. So, kill your responses. Here's your stopwatch. Okay, lovely people. Let's look at it. So we're going to need the same analysis. Everybody pick something, please. This looks pretty good, by the way. Okay, yeah. So this one's we can jump through this one more quickly because you guys this time it's E. Let me try to copy and paste some things from the last page here. Okay, we do have the same issue to deal with as we did last time. So, yeah, and then let me box all these guys up again. So this guy is still the same. This guy is still the same. This guy is still the same color, and this guy is still the same color. So the same analysis as last time. So the first, second, and fourth cases are still automatic yeses to the question. So is R equal to S equal to 3R plus 2? That's still an automatic yes. That's still an automatic yes. That's still an automatic yes. But we still got to analyze this one. So, okay, if we do that, let's take a look. In this case, we know that S is equal to 4R plus 9 and S equals R minus 6. If we solve that, we get 4R plus 9 equals R minus 6. If we keep solving, we get 3R equals negative 15, so R is negative 5. Plugging back in to S, we get negative 5 comma negative 5 minus 6 is negative 11. So this is S equal to 3R plus 2? Well, S is negative 11 and 3R plus 2 is negative 13, so the answer is no. That means overall we have an E. Okay, as far as takeaways from this thing, I mean, we have strayed a little bit from the topic of coordinate geometry, but RP in which question? In which question, where, when? All right, so this is an overall answer of E this time because you have a bunch of yeses, but you also have a single case that is a no. So, right, so that's why the individual statements are P. That's why the individual statements don't work. Because, yeah, that's why you reject the individual statement 1 and statement 2. But then when you put these things together like this, you have to pick one of each bracket and put them together to make these possibilities. But yeah, no, you're right about that. It's got to be one bracket or the other one. But the difference is that when you put the statements together, you have to have one of these brackets and you have to have one of those brackets. That's why you have these 4 possibilities. So, but right, either it's blue or purple, and either it's gold or yellow. So yeah, you got the right idea. Okay, other questions? Otherwise, we're going to look at one more variation on this thing, and then we will be done. See someone else typing something. Okay, no, you didn't. You're done. Okay, one more variation is this one. Again, I love you this much, and I love this problem this much. This time, try that. Give you, again, the deal is pretty much the same, so I'll give you reduced time. Go for it. Okay. James, I hear we're already a few minutes over time, actually, so there will be a recording of this posted in a few days, which you could pull up and watch if you want to rehash that. Okay. Let's look at what happens this time. This time it is a little bit better looking. Again, still the same question as before. The question is R equal to S equal to 3R plus 2? Okay, individual statements this time deserve another look. So statement 1 is the same statement 1 that it's been the whole time, so that's still insufficient for the same reasons. But let's look at statement 2. Statement 2 this time means either 6R plus 4 minus 2S is 0, or 3R plus 2 minus S is 0. But if you, sorry, this is 0, not a 9. If you solve these, here's what you get. This one gives you 6R plus 4 equals 2S, which actually divides by 2 to give exactly what you want. And this solves right away to give you that. So either way, you definitely get a yes to the question. So this one's sufficient by itself. And so we've got ourselves an answer of B. Sweet. Okay. There you go. All right. Sweet. Yeah, I mean, the problems, the original of this guy was GMAT Prep, but I mean, the thing with data sufficiency problems is that they are very sensitive to small changes in the statements, because that's what they're all about, right? Like in this problem, in fact, if you really have been doing this for a long time and you kind of run out of data sufficiency, one thing you can try to do is try to tweak the statements to the problem and see if it changes the answer to the problem. Like for instance, we're done. We don't have any time to go over any more problems today, but I do want to show you what I mean by that. Like if you are, especially if you're at a pretty advanced level with this stuff, like if you got all of today's problems right, like if you're at an advanced level, think about how variations in the statement or the problem will affect the answer. Like for instance, in this last problem here, this Pythagorean triple worked out in two ways, but quadrants and stuff. You could tweak these statements so that, you know, maybe 30, instead of 35, it could be 36. Then you'd have all kinds of possibilities. You have 1 by 36, 2 by 18, 3 by 12, 4 by 9, 6 by 6. So you have lots of things that can happen with different Pythagorean triples. So there's that. Or there was the way that, you know, the last problem went back and forth between C and E and that kind of thing. This one, this is a problem from April 1st. So if you don't know how this problem works, then watch the study hall from April 1st. But let me show you what I mean by small changes in problems, like data sufficiency especially. Like they're crazy different. So like here's a problem from April 1st. The answer to this problem is A. 4110 study hall. And 1 April. Okay, the answer to this problem is A. But if the question is, does M intersect the first quadrant, then the answer becomes, this one becomes C. If the question is, does M intersect the fourth quadrant, then the answer becomes D. And if the question is, sorry, this is last year's study hall. This is 2010. It's an old study hall problem. If the question is, does M intersect the third quadrant, then the answer is B. So, I mean, we don't have time to go over these variations today. You got to figure it out on your own. But the point here is that, like, small variations in the problems, big changes in the answer. It's like chaos theory or something in that way. So, I mean, because what we hear from a lot of people is, like, the comment I got to make about it is a really important comment, is that, like, memorization is bad. If you memorize problems, it's probably even worse than not studying at all. And here's why. Like, if you, like, let's say that you memorize, because this problem's on GMAT Prep, some version of this problem on GMAT Prep. Like, if you memorized this problem, then if you get one of these variations on the test, you're kind of screwed. Like, you're in much worse shape than if you'd never seen it before. Because, like, if you memorize it, you'd be like, oh, I remember when that happened, the answer was A. Well, look, if it's this, now it's C. If it's this, now it's D. If it's this, now it's D. They all look the same, but the answers are all totally different. So if you're memorizing problems, your score might go down. Because you might, if your brain is stuck in the version of this problem that you saw before, and you get something similar, but a little bit different on the test, you're cooked. You're in worse shape than if you had never seen it before. So what you have to try to do is get takeaways about the problems without memorizing the problems. You really have to not memorize. And I mean, if any of you out there are primarily memory-based learners, this is going to be a hard thing to do, but you have to try to do it. Because what I hear from a lot of students who get disappointing scores on the official test is, but they look so much like the OG problems, or they look so much like the GMAT prep. If that's true, that's probably why you're getting nailed, because they probably are these small changes to it, and you're thinking of the old problem that you memorized when you are supposed to be thinking about the new problem. This is a very, very big deal. If you primarily learn by memorization, that has to stop right now. That's easy for me to say, hard for people to do, but it's got to happen. Otherwise, you won't find a lot of improvement. Okay, we got to cut it. We're about 10 minutes over time here. If you have any business-related questions or anything like that, go ahead and shoot those. Otherwise, we are done. The next study hall is in 2 weeks. Usual drill with submitting questions. I can't take random questions right now. If you have a general RC-related question, put it on the forum in the general folder. All right. There's no audio. I think, can you guys hear me? Smiley face if you can hear me. Okay, yeah, you guys can hear me. Yeah, no, we can't take an RC question right now. But if you want to post it on the forum in the general folder, then feel free. Okay. Any other business-related questions? Anything that's not a GMAT academic-related question? Fire away. Otherwise, we're out of town. I'm going to kill the recording here.